And welcome back. I told you guys before last unit that the next couple units would be all triangles, so we're going to continue on that theme. Hopefully you guys did well in the last unit. A lot of calculations, but also a lot of proofs last unit. Not so much this unit, more just calculations, knowing some of these properties, following your definitions, and then setting equations up and solving for some given variable. So starting off with perpendicular and angle bisectors. So we have perpendicular bisectors and we have angle bisectors. Think about what the word bisector means. Okay, we've talked about that before. It means it cuts things in half. So if we have something like a perpendicular bisector, it's going to form a right angle. That's the perpendicular part. And it's going to cut a segment in half. So it does two things. This is a perpendicular bisector. So we're going to go straight into an example. If we look at this first one, XA is an angle bisector, okay, or I'm sorry, a perpendicular bisector, which means it forms right angles and it cuts a segment into two congruent pieces. Okay, so that'd be showing everything I know. Now, if you think about this, and we don't have to prove it, it's not going to be a two-column proof, but I want to know, can we say that XB is congruent to XC? Well, if we remember back to last unit, if we didn't have this information, what we could do is say right now we have a side angle, side angle. You guys got very good at noticing that, okay, AX is by itself a side. There's our third side. So what we've just done is indirectly proved that these triangles are congruent by SAS. You don't have to do that in this chapter, but what you do need to realize is that if we know these triangles are congruent, all their corresponding parts are congruent, which means XB is in fact congruent to SC. So we're going to say yes, and if you want to make a note of it, it's through CP, in congruent triangles. Remember, you need them to be congruent first, and then you can say their parts are congruent. Okay, if we look at another example, again, CA is a perpendicular bisector. Two things it does. Mark it on the diagram, and it'll make your life a lot easier. Alright, we want to solve for x, y, and z. So might as well start with x. So that'll be our first setup. 5x minus 25 is pointing to that angle. We know that angle has to be 90 degrees. I'll let you guys finish it from there. Again, we're trying to find what x will make that happen. That's to find x. To find y, well, y is right down here at AD. Okay, been a while since we've done this, but you guys can handle it. We know that this right side is 3y minus 5, which means this side is also 3y minus 5. In other words, two of those have to be equal to 20. So our setup for y, 2 times 3y minus 5 has to be equal to 20. And again, I'd like you guys to finish that one so we can set them up together. You guys finish them. And your last one, which will take a little bit more work for you guys, but nothing anybody in class can't handle. Z squared plus 8 has to be equal to 6z minus 1. It's not marked, but again, if we look at that example above, if we know that these are congruent triangles, which we do, because it's a perpendicular bisector, we have side, angle, side, again, side, angle, side, we know that these have to be congruent to each other. So that would be our last thing, and then again, we'd get that into our factoring form and solve for z. Make sure you can use both z's, one z, decide what you guys need for those. So solve for x, y, and z, make sure you have those done for tomorrow. Looking at another example, DO is a perpendicular bisector. We want to find all these different things. Okay, so again, think about what it does. It does that, and also we know that those sides have to be congruent because of our indirect proof in that first example. Find everything, shouldn't be too bad. So we know ODR, okay, that's a right angle. So you guys can go ahead and find that. AR, again, if you know DR, you know AD. Add them up to get AR. So you have a lot of different little problems in here, nothing that we haven't seen before. Once we know these properties, once we know what a perpendicular bisector does, this problem should be pretty straightforward. So again, I'd like you to do this one for tomorrow. Again, things that you guys have seen, put a little effort in having these done before class tomorrow. Example 3. We did this back in chapter 3. Okay, finding the equation of the perpendicular bisector in point slope form given that A is 2, -9 and C is 6, 13. Okay, so what this looked like when we drew a picture of it, and I encourage you to draw a picture of it, is something like this. So we have a segment, and this is at 2, -9. This is at 6, 13. What we want to find is the perpendicular bisector. So it does two things to this line. It's perpendicular, which doesn't mean, and some of you did this on your proofs, perpendicular doesn't mean it cuts AC in half. But the bisecting part, so we know it's perpendicular, the bisecting part does mean that it's now cutting AC into two congruent parts. So we want to find the equation of this red line. So we want it to be perpendicular, and we also want it to be halfway between A and C. So to do this, the first thing we did was midpoint. We have to find the midpoint so we know where this point is. So we're going to go ahead and say, and hopefully you remember this, this is our average of our 2 points. So we're going to say 2 plus 6 divided by 2, average of our x's, -9 plus 13, there's our average of our y's. Simplify it, 2 plus 6 is 8, divided by 2 is 4. -9 plus 13 is 4, divided by 2 is 2. So there's our midpoint. That's one piece of information we're going to come back and use. So we know that this is 4, 2 now. Now we need to figure out, that's the bisecting part, we need to figure out what the perpendicular slope is going to be. So we need to figure out the original slope first. So we're going to find the slope formula, hopefully we remember. We have 13 minus a -9, which is going to make it plus 9. This is slope. 13 plus 9, because it's minus a negative. And then we have 6 minus 2. Again, simplify, so we have 13 plus 9 is 22 over 4. Okay, and we'll leave that as a fraction. So let's see, we can divide both by 2, so we have 11 over 2. Now remember, that's the slope of AC. We want the perpendicular slope, which is going to be -2 over 11, the opposite reciprocal. Last thing we do, put in point slope form, which is, I don't want to put parentheses because that won't look right, y minus y1 equals m times x minus x1. Plug everything in. So we're going to have y minus 2 equals -2 over 11 times the quantity of x minus 4. Using the two pieces of information we found, plugging it back in. So again, perpendicular bisector, two parts. Find the midpoint, find the perpendicular slope, put it back into point slope form. Something we've done before. Something we haven't done before, angle bisector. We've talked about it, we know what it does. But if we say we have an angle bisector, we also have, if a point is on the bisector of an angle, meaning right here, if we have C, which is on the bisector of an angle, then it is equidistant, you can think about what that might mean, equal distance, from the sides of the angle. Therefore, in this case, AC would have to be congruent to BC. And it makes sense. If it's cutting the angle in half, it would make sense that AC is congruent to BC. Okay, so if we look at example 4, find x and y if JR is an angle bisector. So we have two things. First of all, we know that this is in degrees, so we have 2x minus 16 degrees is one of these angles. The whole thing's 48. So something actually we really have done before, but just expanding on it. So we have to find x, we're going to have two of those equals 48, because each one is 2x minus 16. So we need two of those. The other side is also 2x minus 16. And we're going to distribute now. So we get 4x minus 32 equals 48. And I know you guys are probably already past where I'm at right now. So we get x is 20. Okay, so you can always double check and make sure that works. If you plug it back in, you should have 24 degrees on both sides, which means you get back to 48. To find y, again, r is that little point there. It's equidistant from here to here. These are the same. So it's as simple as this. 10 minus y equals y plus 2. So I'll add y to both sides and subtract. Y equals 4. X is 20, y equals 4. Okay. Couple notes here at the bottom, just things that you want to make sure you remember you can locate. An in-center is where angle bisectors intersect. So these are all different angle bisectors, and they meet at an in-center. Circumcenter, be careful when you say that. Circumcenter, where perpendicular bisectors meet. So same thing. You have three different perpendicular bisectors. They're going to meet at a different point. Notice how it's not the center of the triangle, which is why we don't call it the center. We call it the in-center for angle bisectors. We call it the circumcenter for perpendicular bisectors. So again, make sure you go back, you finish example 2 and example 3. Got you almost all the way finished with 2. You just have a couple algebra problems to finish there, and then example 3 again, making sure you can fill in those missing pieces. So I'll check that tomorrow. Make sure you have it done in class, and then we will go over some more examples. See you guys.